Here is a video solution for problem number 27 on the Unit 7 review. So we start off reading, a particle moves along the x-axis so that its velocity at any given time is v of t equals sine of 2t. At t equals 0, the particle is at the origin. So the first thing we want to do is interpret that statement, which means if it's at the origin at time 0, then we can say s of 0 equals 0. That's an important part that we will need in part B. But for part A, it says, for t between 0 and pi, find all values of t for which the particle is moving to the left. Moving to the left would mean that v of t, or the velocity, is negative, or less than 0. So we already are given the velocity, so we will take the velocity function, sine of 2t, and set it equal to 0. Now, first thing we have to do is solve. So when is sine equal to 0? Sine is equal to 0 whenever the angle is at 0, or pi, or 2 pi, or 3 pi, or so on. Now, we could also write that as n pi. Now, we want to solve for t, so if we divide by 2, we get at 0 over 2, which would be 0, or pi over 2, or 2 pi over 2, which is just pi, or 3 pi over 2, or 4 pi over 2, or whatever, or n pi over 2. So any pi over 2 is going to work. But since our interval of interest is just 0 to pi, we only want the first three, 0, pi over 2, and pi. Now, what we're going to do is we are going to do a sign analysis on the sine of 2t to see where it is positive and negative. So on our number line, we will put our three critical points, 0, pi over 2, and pi. We know that sine of 2t is 0 at 0, 0 at pi over 2, and 0 at pi. Now, what is it in between 0 and pi over 2? Pick a number in between there. So I pick pi over 4. So if I plug pi over 4 in, I get the sine of 2 pi over 4. 2 pi over 4 reduces to pi over 2, and the sine of pi over 2 is positive 1. So we get a positive value in between 0 and pi over 2. Next, in between pi over 2 and pi, something like 3 pi over 4. If I plug 3 pi over 4 in, I get the sine of 2 times 3 pi over 4, which would simplify to be 3 pi over 2. The sine of 3 pi over 2 is negative 1, so these are negative. So, part A says, when is the particle moving to the left? It is moving to the left when the velocity is negative. When is the velocity negative? On the interval from pi over 2 to pi. So that would be our answer for part A. Next, we will move on to part B. It asks to write an expression for the position of the particle at any time t. At any time t, we are looking for the s of t equation. So we start off realizing that when we are given the v of t equation, that is actually the derivative of the s of t equation. So if v of t, or ds of t dt, is equal to the sine of 2t, then we need to solve that differential equation for s of t. So the first step in solving a differential equation, remember, is to separate the variables. So I have ds of t equals sine of 2t dt. Now, our next step would be to get rid of the differential notation by integrating both sides. So on the left side, the integral of the derivative of s of t is very simple, just s of t. On the right side, we need a u substitution in order to integrate. So we are going to make u equal to 2t, which means that du is going to be equal to 2 dt. I do not have a 2 dt, so that means I need a 1/2 on the outside. So I have 1/2 times the integral of the sine of u du. Alright, so now we'll head up here and we'll say that s of t then is equal to, well, what is the integral of the sine of u? So the integral of sine, remember, is negative cosine of u, but I'm going to replace the u with 2t right away. And then since we are evaluating an indefinite integral, we want to make sure we remember to add the constant of integration. So I have negative 1/2 cosine of 2t plus c. Now comes the important part that we discussed in the first part, that s of 0 is 0. So that means I want to plug in 0 for t and 0 for s of t. So I have 0 equals negative 1/2 cosine of 2 times 0 plus c. 2 times 0 is 0. So negative 1/2 times the cosine of 0. What is the cosine of 0? Cosine of 0 is 1 plus c. So now negative 1/2 times 1 is negative 1/2. Add 1/2 to both sides, and I get c is equal to positive 1/2. So now go back to your s of t equation, and you get s of t equals negative 1/2 cosine of 2t plus c, which is 1/2. And so that would be the position function for the particle at any time t. All right, and finally we will finish off doing part C. Part C says, for t between 0 and pi over 2, find the average value of the position function determined in part B. So, first of all, we have to remember average value. Now, average value, the definition we gave was, we said some f of z is the average value on some interval a to b. If we have 1 over b minus a times the definite integral from a to b of f of x dx. So that means we want to integrate the position function, because we're looking for the average value of position. So we are going to integrate the position function from 0 to pi over 2. So our average value will be 1 over pi over 2 minus 0 times the definite integral from 0 to pi over 2 of the position function, which we found in part B. So that would be negative 1/2 cosine of 2t plus 1/2 dt. So now let's start off. 1 over pi over 2 minus 0. Pi over 2 minus 0 is just pi over 2. So 1 over pi over 2 is 2 over pi times the integral from 0 to pi over 2 of that entire thing. Now, the first thing that I'm going to do is I'm actually going to separate this into two separate integrals. So I'm going to have the first integral, negative 1/2 cosine of 2t dt. And then the second integral is plus the integral from 0 to pi over 2 of 1/2 dt. Now, I'm going to need a u substitution in the first integral on 2t, just like we did in part B. So if I go over to the left here, u equals 2t, then that means du equals 2 dt. So that means, well, I don't have a 2 dt, so I'm going to have to put a 2 in, which means I'm going to need a 1/2 on the outside. So I had the 2 over pi initially in front. Now I have a 1/2 in front, and I also have that negative 1/2, which I could bring in front, which is going to give me negative 1/4. Then I have the integral from 0 to pi over 2, keeping in mind that these are actually t values, t equals 0 to pi over 2, of the cosine of u du. Then I have the second integral plus 0 to pi over 2 of just 1/2 dt. I don't need a u substitution there. And another thing that I didn't write in the first part is that we actually should have parentheses around the entire part so that we remember that the 2 over pi goes to everything. So now I will head up here. All right, so I'll bring the 2 over pi up. Now, the integral of the cosine of u du. All right, so remember the integral of cosine is just sine of u, but I'm just going to put the 2t in right away. And then I have the evaluating from t equals 0 to t equals pi over 2. So I no longer need t equals. I can just put 0 to pi over 2. Then I'm going to add on to that the integral of 1/2. The integral of 1/2 would just be 1/2 t. And we're going to evaluate that from 0 to pi over 2. Now, we have to make sure that our notation is correct. So I put a parenthesis there. and then I'll close the parenthesis here to make sure everything is going to get that 2 over pi. So now 2 over pi comes down, and now I'm going to evaluate. So I have negative 1/4 times the sine of 2t. So that's sine of 2 times pi over 2. 2 times pi over 2 is just pi. Minus negative 1/4, so that's actually plus 1/4 sine of 2 times 0. So 2 times 0 is just 0. That closes off my first integral, and then plus 1/2 t evaluated from pi over 2 to 0. And so that's going to be half of pi over 2 minus half of 0. All right, so now carry down the 2 over pi, and let's simplify. All right, so 1/4 of sine of pi. Well, sine of pi is 0, and the sine of 0 is 0. So really, this is negative 1/4 times 0 plus 1/4 times 0, which is 0. Plus half of pi over 2 is pi over 4, minus half of 0 is 0. So 2 over pi times pi over 4. So 2 over pi times pi over 4. Pi's would reduce. 2/4 is 1/2. And so the average value of position is 1/2.